Now, that said, sunburns can be really bad. You might have to go to the doctor for them if it gets really bad. But what are people mainly afraid of when it comes to UV light right here? What's the main thing people are worried about? Because, I mean, people are worried about sunburns, but that's not, like, the big one, right? Yeah, skin cancer. Skin cancer. And, by the way, eye cancer, right? So UV can cause skin cancer and eye cancer. Visible light doesn't really, okay? And to understand that, let's just go into real quick, like some super basics of what cancer is. I'm oversimplifying this a little bit. If you want the full details, take a medical class or something like that. Now, what is cancer? Do any of you guys know what cancer is? Do you guys know what cancer is? What's cancer? What is it? I mean, something that we all have to worry about all the time. Not everybody knows what it is. What is it? It's something that happens because of a particular type of cell mutation, right? It's a problem in your cells, right? Now, specifically, if we want to be a little bit more specific here, it's a problem with the part of the cell that tells it when to divide, right? There's a part of the cell, which we'll get to in a second, that tells it when to divide. Essentially, what's supposed to happen in your skin cells, and actually all your cells, is they'll live, they'll do their job, whatever their job is, and once they start to get sort of worn out, to refresh themselves, they essentially divide into two new cells, and then those two new cells then live their life for a while, and then they'll divide, right? So slowly over time, and normally, because it's a slow process, some of the cells will die, and the dividing is to replenish your cells, right? In a cancer situation, what's happened is the part of the cell that tells it when to divide gets damaged, and it gets damaged in such a way that the amount of time it lives before dividing is drastically reduced. It's like your cell is like, is it time? Is it time to divide? Is it time? Is now the time to? It's now the time. Now's the time. Okay. And then as soon as they get formed, the new baby cells are like, is now the time? It's the time now. And they immediately divide, right? And then the next group of cells immediately divides, and the next group of cells immediately divides. They don't wait till they get worn out to start dividing. They just divide immediately. And so what is going to happen to the amount of cells in that region over time? If they don't wait to divide, what will happen to the total number of cells? Oh yeah, and a lot of times, yeah, they get deformed because the process of dividing happens so fast it starts messing up. But yeah, the number of cells, more important than the cells being deformed, is that they grow more and more and more and more and more. And essentially that's what a tumor is. A tumor is just a place where you had so many cells growing that they started crowding out the good cells with a bunch of junk cells, okay? So anyway, it's basically out of control life. So here's the question. Do you guys know what part of a cell tells it when to divide? It's the same thing that tells it when to do anything, right? What part of the cell is controlling all of the actions of the cell? What part is it? Now, this is not a biology class, but so don't worry if you don't know these. Give you guys a chance real quick. Got a little bit of a delay here. It's okay. It's the nucleus. It's the nucleus. So in the nucleus, you got your DNA, which is basically the instructions for everything that the cell does. And one of those instructions is how to divide right? But where's the nucleus? The nucleus is inside the cell. So inside these cells, there's a little nucleus full of DNA that tells the cell what to do. Now, here's the thing. That means In order to turn a regular cell into a cancer cell and get that ball rolling, the DNA has to be damaged. The nucleus has to be damaged. So why can't the visible light damage the nucleus? Why can't the visible light damage the nucleus of this cell? Give me that one in the Discord. Why is this visible light not able to damage this nucleus? It's a pretty simple reason. It can't penetrate. That's correct. The visible light doesn't have enough energy to penetrate that much. But the UV light does penetrate, right? The UV light does penetrate. And so that's all it takes to be able to turn a cell into a cancer cell. You need your light to be powerful enough or high enough energy to pass through the cell so it can get to the part that it needs to damage. Does that make sense? Now, here's the next question I have. How many cells have to turn into cancer cells for you to have cancer that could kill you? How many cells have to be turned into cancer cells for you to get cancer that could kill you? How many? Yeah, one. One. It only takes one cell. And so that means it only takes one UV photon to kill you, okay? Now, if you go out in the sun for, let's say, 5 seconds, how many UV photons are you going to get hit by? How many? I don't need an exact number. How many are you going to get hit by if you go out in the sun for 5 seconds? Yeah, a ton, millions. Millions is too low. If you go out in the sun for 5 seconds, you're going to get hit by trillions and trillions and trillions of UV photons. So each one of those could be basically the bullet that gives you cancer, right? And you're getting hit by trillions of them a second, okay? So every time you go in the sun, it's like you're playing Russian roulette, okay? It's like you're playing Russian roulette. So check this out. Yeah. So check this out. Russian roulette. In case you don't know what Russian roulette is, Russian roulette is a game. Don't play Russian roulette. If anybody offers for you to play Russian roulette, don't do that. It's probably illegal. It's a game that involves a gun, right? Like a gun. Specifically, it's played with like an old-timey, like a cowboy gun, like a revolver, right? And like a 6-shooter, right? And does anybody know why a 6-shooter is called a 6-shooter? Don't worry about that. A 6-shooter is called a 6-shooter because it holds 6 bullets, right? Holds 6 bullets. And the way it works is it had that little spinny thing has the 6 bullets in it. If you want to play Russian roulette, and don't play Russian roulette, don't do it, but the way it's played is you just put one bullet into the gun, and then you spin the revolver barrel thing. I'm not a gun nut. I don't know what all these gun parts are called. I think it's called a barrel. You spin it, and so you don't know where the bullet is. And then what do? You put the gun on the table, and everybody on the table goes around taking turns holding the gun to their head and pulling the trigger, okay? And in that situation, 5 times out of 6, you're going to be fine. But 1 time out of 6, what's going to happen? What's going to happen 1 time out of 6 if you play Russian roulette? Yeah, you're going to die, okay? So you don't know which one is going to be the one to kill you, but you're taking that chance, right? Yeah, the odds 5 out of 6 is pretty good, but I wouldn't want to bet my life on a 5 out of 6 chance, right? That said, going in the sun is each of us playing Russian roulette every second of our lives, okay? Every second you're in the sun is like playing Russian roulette with the sun's bullets. Most of those UV photon bullets are not going to kill you, but Every once in a while, your cell will get damaged just right to turn it into cancer, right? Because most of the time, your skin just gets damaged in a way that either kills it or it will fix it. But every once in a while, it'll give you cancer. So that's why skin cancer is so common. And by the way, this is happening with your eyes every time you look at a cell phone. So check that. Keep that in mind as you watch this lecture right now. Yay! All right. Now, that said, if you were to walk to your car today, are you likely to get skin cancer that will kill you? Okay? Are you likely to get skin cancer on your walk to the car? No. Just like in a game of Russian roulette, if you play it once, you're likely to not die. Again, don't play Russian roulette. Please don't. But if you did, you're not likely, if you just play it once, just like one round, you're not likely to die. But the longer you spend in the sun, the more chances you're taking at the Russian roulette, right? So if you play Russian roulette a bunch of times, let's say you had that 6-shooter and you played 100 rounds, you're way more likely to get the bullet in that case, right? So the longer you spend in the sun, the longer you're taking a chance of getting that bullet that will give you skin cancer, okay? And that's why they say spend as little amount of time in the sun as you can. And sunbathing is a bad idea for a long period of time. Oh, and by the way, never go to a tanning booth. Tanning booths, not a good idea. Tanning booths give off an extremely high dose of UV light. And essentially, I think by law, every tanning booth should have the words death box printed on them by law, because you're giving yourself an extremely direct dose of extreme UV. It's just like, hey, you know, that Russian roulette isn't good enough for me. Please load up that gun with 4 bullets instead of 1. That's going to a tanning booth, right? That's my metaphor for a tanning booth. It's loading your Russian roulette pistol with more bullets. So, I mean, I'm not like judging anybody for doing it, but I'm just saying, like, as a health tip, I would super recommend you don't go to those. Just from a scientific perspective, it's a bad idea. Now, what can we do to help protect us from UV light? What are we supposed to do if we're going out in the sun? Yeah, we're supposed to use sunscreen, right? We're supposed to use sunscreen. How does sunscreen work? It's a little bit more complicated than this, but at its most basic, essentially all you're doing is putting a layer of goop in here. You're putting a layer of that's goop, right? Whatever. That's the sunscreen. Why would that help us? Well, remember, UV light is only a little bit higher energy than visible. Visible light doesn't have enough energy to get in, right? UV light has a little bit more energy. So if you put this goop on here, this sunscreen, then the UV light will use up its energy trying to get through the sunscreen. So by the time it gets through the sunscreen, it doesn't have enough energy anymore to penetrate your skin. It basically has lost that power, okay? We've robbed it of its energy. Does that make sense? Hopefully that makes sense. And by the way, the coating in my glasses, that's the same thing. It's just essentially, it's got enough barrier to it to rob the UV of that energy. So by the time it gets to my eyes, it can't damage my eyes as badly. And yeah, you want to keep reapplying because that stuff does not stay on very well, the sunscreen. And also, it's not perfect. So there's no such thing as a perfect sunscreen. So at least some UV is going to still get through no matter what. So yeah, watch out for the sun is what I'm saying. The sun's a big death ball. And the big death ball wants you dead. Okay. Give me one quick second. I'm getting some technical difficulties again. Where are you? There we go. Okay. Sorry about that. So the blue light shield on glasses, that's kind of what I'm talking about on my glasses. There are types of UV filters that you can have on sunglasses and on regular glasses that can block UV, but it's never a perfect block. It's just like the sunscreen. It can block some of that light, but not all of it, okay?